So let's get some vocabulary for working with ratios and rates. So these often come down to working with a fraction. So you'll have some numerator and then your fraction line and then your denominator. So this can be described in a few different ways in terms of wording. Sometimes you'll see something like, we'll see a number 1 here where they give you some information and then say compared to or to some other unit that you're trying to compare. So some phrasing you'll see is like they'll describe the numerator, and that's always described first, and then to, and then denominator. So that'll give you the structure for your fraction in terms of wording. Another symbol that can be used instead of the fraction bar is kind of 2 dots. So maybe they would describe it as numerator, and then a symbol of these 2 dots, denominator. That would also set up your ratio. So a ratio is the quotient, which quotient is just another word for a fraction, of 2 numbers where the first quantity is the numerator and the second quantity is the denominator. So like numerator to denominator in a sentence will be giving you the ratio. Now the key with the ratio is that typically they have the same units. And then if we're describing a rate, it's the same idea of being a quotient of 2 quantities, numerator and denominator, but this uses different units. So for this first example here, it says find the ratio. So since it uses the word ratio, we want to be using the same units. And what we're being told here is 30 minutes to 2 hours. So numerator to denominator. However, right now, we have different units. One's in minutes and one's in hours. This is a fairly simple conversion, so we just need to switch one of them. They can either both be in minutes or both be in hours. Either way would work. In fact, we could look at both cases. Let's use the fact that there are 60 minutes in 1 hour. What that means is that if we have 2 hours, then if we double, so that would be 120 minutes in 2 hours. So what I'm going to do is first I'll do it in minutes, 30 minutes to, instead of writing 2 hours, I'm going to write 120 minutes. So our ratio, we take our numerator, which is the 30, over the denominator, which is 120. And what we could even put in here are the units that we're working with. So minutes were minutes. And what will happen with units, like since the numerator and denominator have the same units, it's like those units cancel out with each other. So all we're dealing with here is a number, which is 30 over 120. And then we just need to reduce that down, which, let's see, if it helps, when you have zeros like this, a little trick I like to use is that the zeros cancel out with each other. Like these are both divisible by 10. So if it helps, you can reduce this down to 3/12 first, and that might make it a little easier to work with. And then we can see they're both divisible by 3. So the ratio is 1/4. And you could even describe it as 1:4. Or the other notation that I wrote up above there, using a kind of colon between the 2 numbers, you might see this as 1, 2, 4. So all of those describe a ratio here for 30 minutes to 2 hours. Now, let's say, just to look at this another way, what if I wanted to put this in hours? So I have my 30 minutes to 2 hours. Let's say instead of 30 minutes, I wanted to put that into units of hours. Well, 30 minutes is half an hour. So what we could do is, instead of writing 30 minutes, we could say half an hour. So this would set up the same. We would have numerator of 1/2 divided by denominator of 2. And this becomes a mixed number like we talked about last week. So this is the same thing as 1/2 divided by 2. And I'm just going to write that as 2 over 1 to kind of help me out here. So with mixed numbers, when we're dividing like this, remember keep, change, flip. So I'm going to keep the first piece, change to multiplication, flip the second fraction, so where it was 2 over 1, now it's 1 over 2. And then we multiply. So the numerator is 1 times 1 divided by 2 times 2, and there's our same solution. So in the end, the units didn't matter, because even if I had written the units of hours in there, they just cancel out with each other, and then that's done. So that would be our ratio there, 1 to 4. Okay, this next example, your car can drive 338 miles on a tank of 26 gallons. Express this relationship as a rate. So this is a case where we have two different units. We have miles and then gallons. Now this one doesn't really use the structure of like one thing to another, but you can usually follow the order that they give it to you in. So I'm going to make that 338 my numerator, and this the denominator, the 26. So I'm going to have 338 miles in the numerator divided by 26 gallons. Now with this one, the units are really important, so I want to keep those included. And then we just notice that they don't cancel out at all, so I'm going to leave the units in that form. What we can do is reduce down numerically. So what we could do is try simplifying. We can also use a calculator to help us out here. So 338 divided by 26 is 13. So numerically, we're just getting 13 out. And then for units, we still have this miles over gallons. Which writing the units like that is perfectly fine, but I do want to show you how we can express those units in words. And how it typically occurs is if you have units that are dividing with each other, that fraction bar can be read as the word per. So how I could write this out is having 13 and then the units in the numerator, so miles, and then per gallon. So we're getting 13 miles per gallon with this car. That's not great gas mileage, but hey. So miles per gallon, you may have heard if you have your car, something we often think about. You might have seen the units MPG come up, and that's miles per gallon as well. And it comes from this division of how far can you travel divided by how many gallons of gas was used to travel that far. And it's in that fraction that we get numerically something out. And then for the units, taking distance divided by gallons, we're getting our miles per gallon. All right, so a unit rate. A unit rate has a denominator of 1. So it's going to be coming through here is we'll have some numerator divided by 1 in the denominator. And then a special form of unit rate that we're going to look at is unit price. And this is where we're going to have a numerator that's in money. So we're going to have some money in the numerator divided by some unit in the denominator. So let's look at this with this example. So we have a 10-ounce box of cereal costs $2.50. Find the unit price. So with this one, notice that we're given 2 units. We have 10 ounces and we have $2.50. And as I've been describing up above, we've been going numerator over denominator. However, since we're looking at unit price, we want the numerator to be money. So that $2.50 is going to be our numerator, which means the other piece of information is going to be the denominator. So we're going to take that $2.50 divided by 10 ounces. Now, this isn't a unit price yet, but it becomes a unit price when we carry out this calculation here. Like technically up above here, this became a unit rate because this is 13 over 1. So by having a denominator of 1 right there, that's actually a unit rate. It just can also be a rate as well. In fact, we set it up as a rate to calculate it, and then it became a unit rate here when that denominator turned into 1. Here we can see we don't have a denominator of 1, but we can create a denominator of 1 by carrying out this calculation. So 2.5 divided by 10, and feel free to use a calculator to help out here. So 2.5 divided by 10, and we're seeing a 0.25. So when we do this, we have 0.25. And then for our units, it's dollars over ounces. So I'm just gonna write it like this. That's not very technical. Let me even do it. Dollars over ounces. So now this is a unit rate because we have a denominator of 0. So by making that calculation, really there's a denominator of 0, or sorry, denominator of 1 there. That's very important. So written like this, it's like $0.25, and then remember that per ounce. So how we could write this out is that this is $0.25 per ounce. So we're getting this cost relating to how much a single ounce would cost. And that's where it becomes a unit price, is that for one of these ounces, how much does it cost?